Okay, so this is a second order linear equation with constant coefficients, and it's non-homogeneous because the right hand side is a function of x. So first of all, we're going to find the general solution of the associated homogeneous equation. So we replace this function by 0, and then we solve by passing to the associated quadratic equation. Remember, replace the order of differentiation with a power. So y double prime becomes lambda squared, and 2y prime becomes 2 lambda. Now, to solve this equation, I can just factor out lambda. So I find that this has two distinct real solutions. Lambda 1 equals 0, and lambda 2 equals negative 2. So I can write down the general solution of the homogeneous equation. That's C1 e to the 0x plus C2 e to the minus 2x. And actually e to the 0x is just 1, so let's replace this. C1 plus C2 e to minus 2x. That's the first step, solving the homogeneous equation. And now we need to find a particular solution. Which I'm going to denote by yp here. So how do we find that? It's by similarity with this function. So this is an exponential. So I'm going to look for a particular solution of the type a constant times the same exponential. So this is the form that I'm looking for. I just need to find for which value of a this function satisfies the actual equation. So I need to start taking derivatives and then plugging them into here to figure out what a has to be. So let's do that. So yp prime will be minus a e to minus x, and yp double prime will be plus a e to minus x. Now let's plug this into this equation because the particular solution has to satisfy the non-homogeneous equation. So y double prime plus 2y prime has to equal e to minus x. And now we can combine this. So here I have, first of all, I can divide everything by e to minus x. That's always positive. So what am I left with? A minus 2a equals 1. So this tells me that a, so negative a is 1. So a is negative 1. Therefore, I know that my particular solution is minus e to minus x. Okay, now I have all the ingredients. The general solution of the non-homogeneous equation is going to be given by the general solution of the homogeneous equation plus a particular solution. So this is going to be my answer.